So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 274, and this video we continue with our exercise, and like all time you read the question, pause the video, try to answer the question as good as you can, and then compare it with my answer, which is also not so perfect, and that's why we watch here in this documentation to see how it is really defined and to learn it, to read it, of course. All right, with that said, let's get started. Here we are on number 12, and now let's read it. First of all, it says create a virtual function example, which means you should just write a code example which uses a virtual function. All right, so of course I paused not the video, I jumped to my, and I'm using just a code which I already wrote in the past. So you can see I have here a class fun, which is my base class. There is one virtual function. Important is a virtual function starts with the word virtual, void have fun, and it is just printing out here that I have fun in the base class. And then I derive from this class fun and to the class games, and you can see I have the virtual function. Again, important is that we have the same name here, and I use here an indicator, but careful, the return type must be not all time the same, but most time it is. 90% it is. If it's not, it is a covariant. Be careful about this one. And then we have here this one here, again just an outprint, and I do one more class. Important is also how you inherit. Here's the inherit for the class. I use all time public, which means we get the public accesses, which means it is like it is here defined. All right, and then so this is a very base virtual function class, and you can see here in my there is one more thing. What I created here is a function which is using, actually you can see the fun base class as a pointer, which must be not a pointer, but it is just a pointer, and here it is just printing out have fun. And then here when we go down, I have here a little bit more things which I will explain later how to use it. So with that said, I hope you created also a class. You can see I created a very simple class. If you created a more complex class, it's even better. That means you know more, and if not, no worry. We concentrate on this example here that was finished, and let's go to the next one. So here it says explain how virtual function work. All right. How does this work with our, you can explain it on your example. So for example, here is my virtual function, again what I created, and now you have to explain it. So I hope you know how does this work. First of all, the virtual function is one time declared in one of the classes, most time in the base class, but not necessarily in the base class. Careful about this. They call it all time the base class. Of course, it can happen that here in the base class, which you derive from, is no virtual function declared at all, and then it starts from here, and then from here derives more and more. And yeah, careful about the word base class, right? So, and then how does it work? First of all, you use the virtual function syntax, and then you override it in the derived class, and you can see here's the override. Careful, this override is optional, but it's a good indicator for starters, which means when you see this override, you know there was already a virtual function declared in the parent class or in one of this higher hierarchy classes, and then it is overwritten here in this class here. That's very helpful to see this one. So you can omit this one, that will work too, like this one, but don't do this, keep that, it's easy. And one more thing, here's our invisible virtual, we don't see it, so this one is also a virtual function because this virtual is also virtual here, it's invisible. All right, and still not answered how does this work. It was just what this is. So how does this work? So when we create a object, and you can see here I create very base variables, and which are objects, and just with the class fun, and when I now create, for example, I'm interested to call this function have fun. So you can see here in my fun class, here is the virtual function. I created here the object base fun class, but it is just a fun, and then I call it. That is what we know. This is without virtual function. This is just a normal call, and that's fine. But now let's say, and the same with the other ones here too. So this is just here. So here I create just pointers, which is also nothing special that we already know. This time I use here the objects here and assign them to pointers. Here is nothing. So but now when we go now to the base to derived classes, so which means when I have here, let's say a pointer, you can see here on top I create here a pointer, and this pointer is base fun class, which means this is a base class, fun class, and this is a base fun class. So nothing special here. But this pointer here is assigning an address of a derived class. And this is special. What is the meaning of this one here? Let's watch this. Here is my base class, and I assigning this pointer to this derived class. You can see when I do it here. In this case. So, and the question is then, hey, wait a minute, why you are doing this one? Because now I want to use normally the virtual function. That's the reason why you normally do this. So because when I later call the derived class, when I call the derived class here, we can see it when I pass it in. For example, in my function, you can see I have here a function, and this function takes only fun base classes, and I want call then, for example, this game's derived class here, what I created here just with my pointer, then I can pass it here in fun, even if it's not the same type, and that's already strange, but careful, we are here in inheritance, and we know the relationship. The derived is R, this is our relationship. If you derive from the base, the derived is a base, so that's why you can put it here. There is an upcast implicitly, that's why this works. But the upcast guarantees not that you can call this have fun. That's why the virtual function mechanism comes in, which means just it checks, okay, you have virtual function declared here, and then I check if this is the final override for this one, and then it checks, it starts here on the base and then says, oh, wait a minute, there is one more defined in the derived, and it is indeed an override, and it is a valid override, so I take this one. So you can see in my function here, I can pass now, for example, this pointer here, which I declared, and then it will call automatically, and that's the nice thing about it, the right output. So it will not call I have fun. It will say, for example, because I will have fun here with games, so the derived class, even, and that's very important, we have just defined here one type. It is the base type. You have to be keep this in mind. And the question is, wait a minute, now why we make this so complicated and not just call it directly? Here I have calls directly, and you can see the problem with this directly call is they have all different types and you can't put them in. And this one is just calling them automatically when you put the base class in, then virtual function, and the virtual function will find the final override here, and that's it. Yeah, that's nice. This is, by the way, it's just only one example. There are much more different examples, but I hope you know a little bit more than me. If not, no worry. So in general, again, more in easy terms, a virtual function works like this. It is trying to find the final override. We talked about this. So it has here an override. It has here the start point with this virtual, and then it checks if there is anywhere a final override. And final override means the last step, right? Okay, I hope you remember this kind of stuff. And here, one more thing, you can see I did this with a pointer, but most time functions like this you will not see with pointers. The pointers are more for if you allocate memory, that's why you need probably a pointer. But in these functions, they are more using what? Reference. Yeah, most time they're using reference, but you see this one is then not working. Instead of this one, let's kick this out. and make here, because now it's a reference, I have to change here the sign. It's a dot. And yeah, then here and here down I have to call the functions with a reference, which means most time you create here this objects here, you will probably have the object, and then you can just pass in the fun param. Let's see what's the wrong. Yeah, the problem is I have here the pointers in, so then you can just pass in the objects here directly without doing anything. So yeah, let's make it so. Let's make here only one example. So I comment the other ones and show you the first one, for example. Or let's say again with the games here. Let's copy this one here. Let's paste this one here, and we have it. So you can see, and this one will work too with pointers or reference here in this case. Important is this virtual function. I mean, is there something else very important? I think it works. I've described it very, very difficult, I think. I hope you know it in more simple terms than me, but yeah, that's so around how does this work, the virtual function. We will go to the example here perhaps to make it easier, so you can see important is that you understand here this base example here. Oops, they have here also this base derived, and then they're creating the base, and then they are using pointers and references, because you must use pointers and references here. It says here anywhere if you want to use virtualization. And then here again you can see they have a base here or a base reference. Here is a base pointer, and then they pointed to the derived one, here to the derived one, and then they can call accordingly the right version through virtualization. All right, then let's go to the next point. I hope you remember this kind of stuff. And then here the next question says, show in your example how to express a virtual function call. So, and pause video, try to answer this one. And here, first of all, what means suppress a virtual function call? Actually, if you understand now what a virtual function is, then you know how to suppress it. What was a virtual function call again? Yes, it is calling. So for example, I pass here in my function the derived form, and then it will know it. So for example, I pass in the object, but it will then automatically resolve through virtualization to the final override. And this is the thing which you should suppress, right? And what I mean with suppress, let's make it easier. Let's go here to this example. Or let's go to my example. It should just call the base instead of calling now this here. So you can see in my example, let's see here. Where's that? Here, when I call here the function, and I am calling the function here where I am calling them. Here again with this one here, if I call here fun with games here in our function, it will use now virtualization, and it will call the derived form, which is games. Where is games? Here's games. It will have this output here. But here we have still the base, right? We have here the base type. And suppress means you should just make it possible that this one is not calling this derived form. Is this possible anyway? And the answer is of course yes. And in my case it's possible here with this syntax. I hope you remember this one here. Important is this one here. If you call the base with : and then the function, it will suppress the virtual function call, and it will just call the base function, which means it will all time print out now I have fun. And again, this one is normal, and two times I have fun. One here, one example I made with pointer, one example is with reference. Both works. Important here to note is, again, you can see this is the example from above. That was this this one here it would call normally it will call this one I have fun with games, but because I call exactly the same thing differently with this syntax here, it is not use virtualization, which means it will call I have fun instead. And you can read this again here in this little example. Again here, a non-virtual function call. This is the syntax that what I used as well. Important is you just specify the base and then this colon, and here is in this sentence how to suppress that. So, and there is a little bit more actually, which I have not wrote, but I think that's enough for our little step. And in the next video we go here a little bit more. So if you have any questions like old time, write in the comment section. See you in the next video. Good luck, have fun, and like old time, never go up. Bye.